4.2.3 says calculate the area of triangle BCD. Now triangle BCD, I've outlined the side BD in green such that we can see the area of which we need to find. That would be this one over here. And within this area, we can see that we have the side 6, and we know there are two formulas that we mostly use in order to find area of a triangle. One which is usually simpler than the other would be the area is equals to half times perpendicular base times height, or perpendicular height times base. It doesn't really matter which one you use, as long as the height or the base and the height have a 90-degree angle between each other, then you should be fine. Then the other formula that you can use is area is equals to half BC sine A. Now BC are the two sides that sandwich our angle A that we may have. So in this case, the easier method would be to take this first formula, where you can take your base as 6 units, as this one. Then your height is to come perpendicularly from your base. So if we start perpendicularly from our base and go up straight, we get to that highest point there, making this our 90-degree angle. So if we can somehow find the length of this, this will be our height, and our base is 6. So if we look at the properties of this, we can tell that at this line over here, the y value was 7. So C had coordinates -1 and 7. And the coordinates here are -4 and 2. But we are mostly interested in the y value because that will help us gauge just how much it takes to get from that point to this point. So 7 minus 2 gives us 5, which is 5 units. The other way that you can think about it is if you draw your line over here. It doesn't really matter where you draw it, as long as it's coming from the highest point on your triangle to your base, and it moves perpendicularly. We can see from this line that I've drawn that our radius is this, which is 4 units, and then we have this extra part over here that goes 1 unit down. So from 3 to 2, that is 1 unit. So in total that makes 5 units, and we can write that in. So our base is 6 and our height is 5. So this will give us a half times our base, which is 6, times our height, which is 5. This gives us a total of 15. So that will be 15 units squared. If you decide to go this route, there will be a bit more calculations involved, as you will be looking at it from this perspective. So you would need a reference angle that you would be using to calculate this, your sine A. Your sine A, you can choose this angle C, and then we extend this line BC such that we are able to find its inclination angle. If you can find this angle, then you will be able to find this other angle on the other side, and this angle would be the same as this angle. So that's how you get your sine A, but you still need to find the distance from B to C. So you need this length, because your formula will be a half times, let me write this in black, that will be a half times our base, or not base in this case, just the two sides, which will be 6 times the length of BC, and multiplied by sine of A, which you would have found at that point. So the only unknown is this one, of which you can use the distance formula. BC is equal to the square root of the change in x squared plus the change in y squared, like that. You can pick the two coordinates B and C. You've already calculated the coordinates, and then you can just plug that in and work this out, but you're sure to get the same answer. But here recommended would be this method.